Good morning, Mrs. Reynolds, 3rd, 4th grade class. We are here to present heat energy for you today. I am Jennifer.
I'm Melissa. I'm Jenna.
Hi.
All right. So everybody knows that it's been super, super hot lately. Is anybody tired of the heat? Yeah, me too. What do you think of when you think of being outside and being hot? Sweat. Summer. What do you do when you get hot? Swim? Go inside. Why do you go inside?
Air conditioning.
Oh. All right. So on a hot summer day, you're extremely hot. So I'd been mowing the yard, and I was so hot. So I'm like, I'm going to go get a couple of ice cubes. I'm going to put them in a baggie. Hopefully that will cool me off. What do you guys think? Do you think that would help?
For a little bit.
For a little bit? Andy, why do you think it would help for a little bit?
Because the ice cubes would melt in the sun or on your skin.
Ooh, why do you think they would melt?
Because they're cold.
Yes, ice cubes are very cold. So Andy brings up a good question. You know, he thinks that they would melt, but he thinks they would melt because they're cold. What do you guys think?
Cold things stay cold and hot things stay hot. So maybe they won't melt. That's an interesting idea.
That we're gonna check that out though.
During our explore phase.
So
wait, hold on, interrupt. So, what do you guys think? Do you think she should have followed up with a question and like probed her thinking, or just kind of kept going?
The question would be, why do you think that, right?
You
Or
could.
something like that.
Okay, let's hear it. So, why do you think cold things stay cold and hot things stay hot?
Because when I eat my ice cream, it's cold the whole time.
The whole time? But what happens, let's say you have a cup of hot cocoa. Okay?
Okay.
So what happens if I sneak up behind you and I drop a couple of ice cubes in that hot cocoa?
Then the ice cubes are going to get hot.
They're going to get hot?
That's actually a really good.
Yes.
That's a really good
So,
comment.
why do you think the ice cubes are going to get hot?
Because the hot cocoa is hot.
Okay, the longer you look at your hot cocoa, what happens to the ice though?
They melt.
They melt. Why do you think they melt?
Because they get hot.
Because they get hot? So, let me see. Do you think...
Okay, hold on, I'm gonna interrupt here. Now, this is good. Melissa's like really into the questioning.
I don't know.
Now, you don't, like, you want to ask questions, but you don't need to teach her the right answer. But you want to ask questions, and this is awesome. And what's really cool is Megan's actually giving some of the accurate, she has a really interesting combination of, like, accurate thinking and misconception, which is kind of cool, right? Because it's not actually the ice cube. Well, I'm not going to do it. Okay, so good questioning, but you don't have to change her mind in the engage phase. But we want to get her thinking in the engage, and we don't need to have her change her mind yet. Okay, good. Keep going.
So, how about we do this? Let's have one person from each table. So pick a person and have them come to the front. Kirsten. Patrick. Amy. Wilson. Or she can come. It's fine. No. Alright, so what you're going to do is you're going to get a little baggie. And if anybody is a Sheldon Cooper, there's extra baggies. I don't know if you guys know who Sheldon Cooper is.
I don't think these kids will.
Alright, so get some ice and put it in your baggie and take it back to your table.
He's making a mess.
Now Patrick, you can't play in the ice.
Do we get hot cocoa today?
No hot cocoa today. All right. Does every table table have a baggie of ice? Yes. Okay, awesome. Now, as a group, pass the baggie around, hold it in your hands. And while you do that, pay attention to what happens to the ice, what happens to your hands. So, Kirsten, what happens when you hold the ice in your hand?
My hand got cold.
Your hand got cold? Why do you think your hand got cold?
I think it got cold because, like, the hot from my hands and the cold from the ice are, like, fighting each other to, like, win to see if, like, my hand's going to get cold or the ice is going to get really hot.
That's a great idea. So does anybody else agree with Kirsten, or do you have different ideas?
I agree.
You agree? Ashley, do you agree? Richmond?
I think that my hand got cold because cold things cool down warm things.
You think so you think the ice is cooling down your hand?
Yes.
Yeah, that's a great idea.
Well, that kind of leads us up to some investigation questions we had. We thought maybe you guys could help us figure out, if we give you a container of hot water and a baggie of ice and a thermometer, how we can measure the answer, what will happen when a cold object, your ice, comes into contact with a warm object, the hot water.
So what we're going to do is we're going to have you write a prediction. So what do you think will happen when you put your ice in the warm water?
So we'd like you to also think about, as you're writing your predictions, if you added heat to an object, what would happen to it? And see if maybe that would help you think about your prediction as you're writing. Are we supposed to fill in all this?
No,
So this would be a great time to practice an attention getter. When we go and observe, we're going to see what attention getters the teachers use. What's an attention getter that you guys like to use as teachers? Do you know what I mean by attention
You mean
getter?
like match numbers?
Okay, 1, 2, 3, eyes on me. So Jennifer, why don't you say 1, 2, 3, eyes on me and restate your instructions?
Okay. 1, 2, 3, eyes on me.
1, 2, eyes on you.
Thank you. Let's try that again. 1, 2, 3, eyes on me.
1, 2, eyes on you.
Wonderful. Okay, as you're forming your predictions of what would happen to a baggie of ice as it's put in the hot or warm water, as it comes in contact with a warm object, it might be helpful if you think, what would happen if you add heat to an object? What happens to it? That's one of our questions for thought. Just think about it. Just something to think about. What happens when...
I think that's confusing.
In other words, if I add heat to the ice, what happens to the ice?
Are we adding heat to warm water or heat to ice?
Heat to your ice.
We put it in the microwave.
Like by putting your ice in the hot water. Because you're adding the heat to the ice.
water is already hot. So to the ice.
You're adding the bag of ice. The ice.
All right, guys. So this seems to be like a little confusing. So what if we change this up a little bit? So let's get rid of this. All right. So let's let's do it this way. So, what happens when you add?
And I think you should use that container because it's a little abstract. So since your question's really specific to your investigation,
Mhm.
I would like pretend that there's hot water in there. When you do it with the kids, actually have hot water in there and,
Okay.
and use that.
Okay. So what happens? I'm gonna borrow Amy's baggie of ice. So what happens when we take the ice, which is a cold object, and drop it into the warm water? What do you think happens? So on this front page, write your prediction of what you think will happen. She is not. So Megan, why?
I think it's because that's what my mom told me.
That's what your mom told you? So
My mom's right, always.
you know what? I would have to, but if you are 99.9% what? What do you think about ethics? And what it does is like cut the holes, but keep that in mind. Right? Okay, I will. Okay. Keep it. You'll keep it.
Oh, you're fine. I think that the ice will sorry, the temperature of the water will decrease, excuse me. Decrease because once it's finished, but ice and water melted, and then I put my finger in the water and I got a lot colder.
Because I saw ice melt
Be more like
I think, yes,
All right, guys.
Ice, frozen water, that's a very
Awesome. So, Amy, what's your prediction of what's going to happen?
I'm not done yet.
You're not done yet. Richmond had a good one. Richmond, what do you have?
I said I think the ice will melt and the temperature of the water will be colder.
Why do you think the water will be colder?
Because the cold water is going to spread out and it'll make it colder.
That's a great question. So, does anybody agree or disagree with Richmond?
I agree.
Chelsea, you agree? Why do you agree? What do you think she said is right?
Because when the ice melts, it's going to be cold water and mix with the warm water.
And it's going to mix with the warm water?
It's going to make cool water.
It's going to make cool water?
Yes.
All right. Anybody else have a different prediction as to what's going to happen? Megan.
let's hear Jenna do some. Jump in there, Jenna.
Sure.
Does anyone have any disagreements with Richmond? If you have a disagreement, raise your hand. Ashley?
I said the ice will stay the same and the temperature of the water will stay the same.
Why do you think it will stay the same?
Because Olaf lived in the summer in Frozen.
That's such a good one.
Are there any others who disagree with Richmond and Chelsea? Erica?
I said that the ice is going to melt, but the temperature of the water will stay the same because it's like a really big cup of water. It's so big that it does not matter.
Yes, good. Why do you think that?
So when you're doing the engage phase, you're asking questions because you're looking for like little pieces of information that you want to pull out, right? So out of that answer that Erica just gave, what strikes you as a teacher that's important to notice from her comment?
She said that the bigger the object, because it's the bigger object, it won't cool down as fast. Is that what you said? Or it'll stay the same because it's too big to circulate.
Yeah, that's what I think.
So what are you thinking as the teacher? What is your teacher brain thinking?
That concept between, I don't, that she like knows like it takes longer to do things if it's a bigger object, or I don't know.
Yeah, so something about size and something about, like, you'll probably want to remember that and come back and ask her later and follow up with her in terms of, can it be the size? Is it like how much cold water it is? Is the cold water moving into the warm water? And just a lot of good ideas about how to transfer heat energy. Good, so we're going to end there. I think we should talk, group, about revising your IQ and